Welcome, problem solving fans, to another problem of the day. And this one's all about Neil and his counters. It says Neil gives 40% of his counters to Ben. He then gives half of the remaining counters to Stacy, and he's got 36 counters left. How many counters did Neil have at the start? Well, we could do this in a couple of ways. We could do it with a bar model, or we could do it by thinking about percentages and fractions. So let's have a think about it first using percentages and fractions, equivalent percentages and fractions. So, if he gives 40% of his counters to Ben, that means after he's given 40% of the counters to Ben, he must have 60% of his counters that he started with left, because he started with 100%. So we need to remember he starts with 100%. It doesn't actually say that, but that's what it means. He's starting with all of his counters. All of his counters is 100%. And he gives 40% of away, so you take the 40% off, he's got 60% left. He then gives half of the remaining counters to Stacy. So half of this 60% that's left would be 30%. So he gives away another 30%. So we're going to take away another 30%. Which means 60 take away 30%, he's only going to have 30% of what he started with left. But that 30% is worth 36. So, if 30% is worth 36, then we need to turn this back into 100% to figure out what he started with. So if you divide that by 3... 30% divided by 3 would give you 10%, but you've also got to divide the 36 by 3, which would give you 12. So 10% must make 12, and then from there we can build this 10% back up to 100%, which is what he started with 100%. So to get from 10% to 100%, you would times that by 10. 10 times 10 is 100. So if you times in the 10% by 10, you've got to times the 12 by 10. And 10 times 12 is 120. So he must have started with 120 counters. 100%, which is what we said earlier, is what he started with, was 120 counters. So the final answer is 120 counters. Now there is another way we could have done this, like we said earlier, and that was to use a bar model. So we'll have a little go at this as well, using the bar model, but we just need to make a little bit of space here. So, if we're dealing with percentages and 40%, then what it might help us to do is draw a bar split into 10 sections, where each of the 10 sections is worth 10%. So just doing this now, making a bar with 10 sections, and each section is worth 10%. The whole bar, don't forget, would be worth 100%. Now let's try and run through that again. So, Neil's got some counters. He gives 40% of his counters to Ben. So, 40% would be, because each section on the bar is worth 10%, 40% would be 4 sections. That would be 40% gone. That's his 40% gone. So he's got 60% left, but he gives half of these. So the bit that's left, we're going to split in half. Well, there's 6 squares left, each being worth 10%, so you split that in half would be 3 squares. So he's giving away 30% to Stacy. So this is the bit, these 3 squares, 3 lots of 10% is what he's giving away to Stacy. So let's just write 30% on that. And he has 36 counters left. So the remaining 3 lots of 10% must be worth 36 counters. It says here 36 counters. So that's what he's got left. Well, this needs to be split between 3 bars, so that would be 12 in each bar. So if there's 12 in each bar, that means there's 12 in all of the bars, in all of the sections of the bar. And all sections of the bar are worth 10%. So if there's 10 sections of the bar, all worth 12, that's 10 lots of 12, which is 120. Which again is another way of explaining why the final answer is 120.